Today I'm going to talk a little history lesson, a history lesson that I experienced. We're looking at the evolution of automotive systems and tools and how they developed over time. I guess I was lucky to be born at exactly the time when everything started to change. The late 70s, we seen the first implementation of computerization, and all the way up to now with the AI systems in Teslas. So we have the complete spectrum, and I guess I'd say I've been fortunate to see. So let's go on a journey here and talk about the different experiences and what one had to go through to be a tech and be familiar with what's going on in the different technologies that are out there. Very late 70s, and entered the automotive arena. Name's Robert Braun. I actually worked at many different independent shops. I always had a side gig, always. Till to current in retirement, and from a teenager, I was fixing cars. So in one form or another, 100% of the time I had a side gig, but I had many professional careers. So let's get on with it here. So in the late 70s, I was doing repair, finished up school. I was going to General Motors Training Center, having a chance to learn that technology and seeing the very beginning of the systems that were coming out. And also, that was when I recognized the need to get ASE certified. So, late 70s, I ended up getting my first certification. By the early 80s, I was a master ASE tech. Tests were quite different. Same technology, nothing's changed there. Same technology, but they were quite different in pencil paper. Studying the questions probably weren't as clear. They weren't as complicated, I can tell you that, because we just didn't have the complication in the systems itself. But I was so interested in tools and equipment, I had the good fortune to actually go to work for Sun Electric Corporation as a field instructor. I was pretty young, I imagine, but I went out there and I was the guy that would go when the Sun machine was sold to the repair shop and do the training. Some of you watching us may remember them days. So what we did is the equipment was sold, and the technicians were hungry for the knowledge on how this equipment's going to be used. They're also interested in what this new technology was starting to develop out there. So in the early years, we had C4. That was the system in the C3 was a system in the late 70s. That was GM's mixture control solenoid design, relatively, in today's standard, rudimentary computer. But when you have had no point of reference to this, it is actually quite exciting, quite scary. In fact, I can remember the first EEC-II systems I worked on. That's a Ford. Emission systems with the variable Venturi carburetors, the first mixture control solenoids that I had a chance to take apart. And that was really quite an era. My experience kind of from the very beginning was the DuraSpark. So Ford's DuraSpark system was out there, and that was basically a very rudimentary, of course, to today's standard, but a means of varying timing, computerized timing systems. Really had little or nothing to do with the fuel, but we did a lot of adjustments because remember, that was big time EGRs coming on board. We had to keep the knock control, so knock sensors were just starting to form, and they were adjusting emissions based on engine temperature by adjusting the timing. So then came the Chrysler lean burns. Man, I worked on a lot of them. That was a rough era because that was an analog device. It didn't necessarily work all that well. It was pretty rudimentary. Then I would say the very first the first fuel injection systems I had a chance to cut my teeth on were in 1978. Toyota had their electronic fuel injection. I did work on some of the Cadillac DFIs, that's a digital fuel injection systems. So they were real early on. That was actually, take that back, that was I think 1976. And that one actually was really neat to think about triggering devices. That used reed switches, little like would be in your wall thermostat, your older style wall thermostats. Literally, it would simply a little mercury tube that would, with a contactor that would open and close when there was a little bit of contact with it. I guess we'd say a little magnetic contact. The C3 system, that was really one of the first ones to my recollection, and I'd seen quite a few of them because they were really not well designed, come out. And with the early fuel, remember we had a lot of other things to contend with. We had evaporative emissions were a biggie. We had the conditions there. We had the beginning of all these vacuum hoses that were running everywhere, and that was part of it. So that was the transition from the vacuum hose to the computerization. Some companies, example Toyota, specifically Honda, just had a smorgasbord underneath the hood of hoses and solenoids, where eventually, like General Motors, they had really cleaned it up. They had done a lot more with simply putting in the electronic components. So solenoids and relays were starting to find their home underneath the hood. So remember, at this time, we came from a point of adjusting points. This was a high-tech tool of that era. This was something in everybody's toolbox to adjust the points on a Delco distributor. So we went from that within literally, let's say, from 1974 to the early 80s, so 8 to 10 years to full computerization. That was a massive leap. No one out there, remember, no technicians had any point of reference. I went into an era that, as I was entering industry, everybody was fleeing the industry. It was a very interesting historical time of the number of technicians that said, I'm not working on this stuff. I don't understand it. I don't want to deal with it. I'm not going to work on it. And the young technicians, some of us were interested. I had a dual personality, nothing but muscle cars, 428 Cobra Jet Mustangs, 440 Cudas, that was it. But I learned how to earn a living, and that was on all the emissions. So we weren't thinking about computerization as we do today. Everything was referenced to emissions. So that was the point of reference. And actually, being in southeastern Wisconsin, growing up in Racine, and then on a big farm, and then moving to Kenosha, where I had bought a place down there. I had a chance to be right at the the epicenter from one region on the automotive technology changing. So as an example, let's just go for the numbers here. By the early 80s, I had seen us go from EEC-1 to EEC-III systems. I had the C4, C3, and then the C4. And then I had, I wasn't too much on a lot of the Euro cars, but I did a fair amount of Bosch systems, the L-Jetronics systems. And then some of the big things started to hit. I think back to 1984 when Ford came out with the EEC-IV system. They had their TFI system. Boy, these modules of that era and the Hall effects in them were quite astonishing, knowing what all the pins were and trying to figure out when they would run intermittently. Remember, that was the era of the beginning of intermittent problems. I have to think back. One of the interesting ones is, I would say in the 70s, before I really touched this stuff, I would say as a 16, 17 years old, I remember working on a Boss 429, helping out with that. It had a rev limiter in it. Nobody understood how this electronic component worked. The 1970 Boss 429 in it, and it would only make it about 4,000 RPMs and cut out. So that was the highest tech, and all the brain trust of everybody was working on this. A decade later, from a service standpoint, we were dealing with computerization and having to learn how to use the test equipment. Now the Sun machines, the Allen machines, the Snap-on have all been out there for some time. So the guys were actually pretty darn good at looking at waveforms of ignition. So we understood that. But the actual electronic components were so new. And then I was thinking about when we got into Chrysler started coming out with their integrated ignition module designs. So there's like the Omni Horizon, the K-Car series. That was quite a challenge to get them carburetors to work right. They had their own design. Remember, everybody had their own plug-in. That was not an era we had 16 pin, we could almost memorize what everything is. Everybody had their own standard, and within them standards there were substandards that you had to remember and try to figure out where the plug connector was if you were going to plug in a scan tool. I remember I bought my first handheld scan tool was an OTC, I think it was a Monitor 2, a little LED display on it. We would view that as a code reader today. It would get codes and a little bit of data, but it's all the systems actually put out. But the time went on and I got more experience. My years of training with Sun Electric, my repair, doing other seminars, basically kind of entering into the teaching world. Then in 1986, I was very involved actively with the automotive arena, and the gentleman, Jim Peel, who was in charge of the research and test lab at Snap-on Tools in their worldwide headquarters in Kenosha, said, hey, you'd be, I think, a good candidate for my department. And I applied for a job and I received it. And suddenly I went into this world of diagnostic development. So I had a chance there to look at it from a different perspective. When I was teaching with Sun, I was still looking at it from a vehicle troubleshooting standpoint and integrating the equipment in. When I went to work for Snap-on, we ended up looking at it from a totally different perspective. That perspective ended up being, how is the technician going to fix the vehicle with our piece of equipment? So the MT1665 was the one I came in just as that project was kind of finishing up, so I had a chance to see a completion of a project. I did have a fair amount of input into it, put together a lot of the training materials, tested endless hours of testing, and working with the field, going out and talking to technicians and finding out, my peers. I didn't come in it from like a lot of the engineer staff did, where they were, looking at it, didn't really know how to fix the car, but they knew how to design. I came in it from knowing these were my peers, these are my buddies, these are the folks that I work with. They are just working, making every day they're earning a living, wrenching. Every day I'm earning a living, making wrenching easier for them. So that was that process that I went through. But I still had to stay up on top of what was going on with the automotive technology. Otherwise, I'd have been of no value whatsoever. So we were in the late 80s thinking about the next product. Next product was the MT3000, the counselor scope. And I had a chance there to live that. I have a whole series of U.S. patents, and that was all because I had this experience, and I think I'm very blessed because I had so many friends that were technicians that could actually help me and guide me through. So that information was put into this unit. I was, I guess we'd say, part of the diagnostic team that did all the development. So we looked at it from a diagnostic arena, and then we put it into the development. But I was just thinking back to all the books. So understanding the oscilloscopes. I had to train this with Sun, and look at what we had to deal with of that era. We had to look at these waveforms. We analyzed ignition waveforms to the finest detail. So that was the skill set, but each guy that came into it had to learn it. It was something. Plus, at the same time, all of a sudden, all this other information was coming on board. And that really was quite a challenge. Here was the schematics here of the early EEC-I and II systems, where we still had a Duraspark system on it. We just had a conventional ignition module, but we had an electronic module that would vary the timing. And then very shortly thereafter, we came up with the where the fuel became a thing. So chasing us around with in the environment of automotive service got to be a real challenge. Even when I was in the cutting edge, and I was constantly going to classes, seminars. I was going over to Detroit to learn from the manufacturers, seeing what was going on at GM Proving Grounds, GM Service Research, Ford, Toyota. I mean, I was going the whole gamut. And it was moving along so fast, and I remember saying a lot of things. These cars are going to become unfixable. Nobody's going to be able to fix them. They're so complicated. Now you think back to the 1980s cars, not so much. But it's interesting, when you're looking up the mountain, it's quite different than when you're looking down the mountain. I was just thinking, my reading, things that I would just literally, I still am, a readaholic. I would sit there and I would go through book after book. I have an extensive library. Oh, look at these, I'm in a bookmark. Whoa, a lottery ticket. Is that any good? From 1986. Huh. Anyway, so we would go through. This is what I would do. I learned and learned and learned. So when the MT3000 counselor came along, and I was part of the development team, I also was part of the team, along with some pros. I mean, there was some awesome people that I had a chance to work with. And we wrote the counselor manual. And I think in some respects it was quite a feat. We had a lot of the conventional stuff of primary, secondary ignition and so on. But where we really prospered was we got into a lot of the components, how to test the components. We put this right into the operator's manual for the instrument, recognizing, and this is with that the technician had to have this information. It wasn't only about how the buttons, each one of the buttons work on here, but how do you actually apply it in an environment that can allow you to make a living with this? Is this going to be a value added? I always looked at it from that perspective. Because when I worked for Sun, going back a little in time, I had bought one of their entry-level scopes. It was called Sleuth 2. And it was good. It was a pure analog scope. It worked. It was the cheaper version. Cheap being relatively speaking. I think I paid $7,000 for it. So I recognized when we got into development that we had to think about how technicians are going to fix cars. And I remember a gentleman at General Motors Training Center, a fellow by the name of Don Fritz. He was their head instructor in their AC Delco program. And man, it was awesome. I think I had, one time I looked, I think it was almost 400 hours over a 20-year period there, just taking endless classes, both before I worked for Snap-on and then after. And they treated us well. And that's why he always talked about, don't forget the basics. So that's where the vacuum probe. So the vacuum analysis and the vacuum probe, I guess I'll brag a little on that, I was instrumental in this technology. It wasn't exclusive, but we had really pioneered and made it really work, and including to put that information in the manual. And we all know what misfire codes are. P0300s. Well, before there was a P0300s, there was the power balance probe. This was used on the counselor scope, and what we would do is we would actually have this put onto the belt on the vehicle, and it would find increase and decrease in engine velocity. So each cylinder firing you have, the engine increased in velocity, and then of course if we had a misfire or a partial combustion, we would see it slowing down, and then we would look at that across the waveform here. And I'll go in more depth in a future video on this. But that was the technology. So there was an arms race. There wasn't anything called misfire detection. And it was getting harder and harder to hook up a scope to actually get this information, because more and more we had DIS systems. We were starting to get a few early coil on plugs. So they really kind of changed everything. Then the 90s arrived, and that was kind of the big thing, was OBD, onboard diagnosis. So the onboard diagnostic system was really put in place, and there was all these different systems out there. We had GM had their C4 system, then it was, that was the OBD1, and then they moved into OBD2, Ford EEC-IV systems that had moved rapidly from that transition from relatively simple. Remember, example, in 1994, that was the beginning of the rollout for OBD2, our 16-pin beloved connector we know today. And by 1996, 100% of the fleet had to be. So it was a third, a third, and a third. So you had all these orphan systems that were almost at OBD2, but not quite. They had their own connectors. Some had both style connectors on it. Actually, that went on for a few years. From an equipment manufacturing standpoint, that was really a tough time. We had the MT2500 scan tool. That eventually, turned into the Modus and so on. But at the time, that was really a challenge with all these endless adapters. And now you started having this bridge between, can the technicians repair it looking at the scan tool, or can they repair it using instruments from scopes to meters? So where did that end up? That I could say in some respect that battle still goes on to this day. But it was really an interesting time because there was technicians that would just chase codes down, and some were relatively successful. Everybody's got an opinion on this one, I know for a fact. But what we'd find is we would have the situation here of technicians would go down a path following the troubleshooting. Others would treat this as a system. I know how it works, and I'm going to use a lap scope. I'm going to use meters, current probes. I'm going to use all that, and I don't really care what name tag is on the vehicle. I'll use the code as a reference to get me in the right area, but beyond that, I'm going to look at. That was the two difference. So I talked to both technicians. We were trying to address both of them. I would work back with marketing and try to convey that information back to marketing and go, hey, this is what the technicians are saying. And then literally, next time I'd come in, well, this is what they're saying. So we were going in different directions. But one thing is that technology was getting more and more sophisticated. And you got to keep in mind, looking back down the mountain, we were still trying to fix all these cars in the 80s. We still had cars from the 70s with vacuum hoses on it. A few rare ones out of the 60s were being serviced in a service base. So that's where that trajectory went back down. So we learned an awful lot. And then we got to the very end there, and we got into the 2000s. And by the 2000s, I had left Snap-on. I did a lot of consulting work. I had a company that I will talk about in a future video. And then in the early 2000s, I went to teach at the technical college, the one that I had graduated from. And that was a wonderful experience. I was able to take this knowledge that I had gained over now decades of experience and convey that to young students. Not necessarily young even, but to students. And that was quite a exciting time. So now I really had to apply the knowledge, and I had to teach them backwards. And I always remember in Engine Performance 1, I always had one module on ignition points, and I would show them how to use a high-tech tool. And like some of them I'll never work on, and the other ones, we got all these collector cars. So it was a valuable tool. But I also wanted to show that evolution of where we went, simply just following the ignition system down. And then I would teach a fuel systems class, and I'd go from your basic carburetor to some of the early ones that put anodes in them. For barometric pressure, then the first mixture control solenoids, and then the rapid transition to fuel injection. And think where we're going with fuel injection. Now we got a direct injection. So I mean, them and all these variable cam timing, the stratified charge systems in the injection. So it's a lot to know about. And each manufacturer kind of comes up with their own theme. I was thinking about where Chrysler was kind of running ahead, and then General Motors, and then Toyota. There was just this battle going on. And you got to think about 1990 to 2000, a 10-year period. where we were just starting to understand how the system works. And my opinion, that late 90s, early 2000s were the easiest time to fix cars in my whole entire life, because they had standardized, they had stabilized. That was really quite a time, because they modeled a model from that late 90s to early 2000s. There wasn't massive changes. There wasn't that much. I got very interested in the Toyota hybrid synergy system. I thought it was pretty neat. And now believe it or not, I got a fleet of them things. I got muscle cars and Priuses. Who else? Anyways, I thought that tech was interesting, and I saw it as being a new area to learn. I was always interested in learning, so I made it an effort to become very knowledgeable. I had a chance to go to Toyota's school, and then there was some other manufacturers that were kind of putzing around with. Ford had their system and their Escape and so on. So I had a chance to learn that, and that required yet a new set of skills and new tools. And them tools all come with a price, and that knowledge comes with a price. That's endless. And I should have grabbed it here for the video, but just imagine for a moment, I went from pure books to VHS tapes to DVDs, and now to everything online. What a transformation. But guess what? If I was learning about the DuraSpark 2 system, or the latest in a Tesla battery management system, it really does all work the same way. That's the beauty of learning electricity. Once you understand the basics of electricity, when you understand it, have a depth of knowledge, it almost gets easier and easier and easier. Then let's move forward here. Then we got into the 2000 teens, and that's where things really started getting crazy. So now we had some kind of early rollouts here of EVs. We had different fuel strategy. Direct injection became more and more of a thing. And we had this integration of the systems. And you got more telemetry designs. And each one of them were really getting to be quite challenging. I noticed that all of a sudden the technicians were really starting to get challenged again, because there was this rapid change. We were developing the early levels of ADAS, so you had collision avoidance, the real early systems, the cameras being mounted all over, a whole new area of knowledge that technicians had to understand. Let alone go back to the basics, they still have basically electrical problems. And so you deal with everything from a battery going dead from a parasitic draw to lights that are bad, that are dim. All them basic electrical problems are still there, along with all this high tech. So the amount of knowledge. Now we're way high up in the mountain, looking back down, and it's always interesting. I talk to younger guys, and they get challenged with some friends got a collector car, relative, whatever it is, and can you work on my carburetor? It's got points in it, and they look like a deer in a headlight. And I think this is like going back to first grade, and you're at a senior in high school or college level, and you're challenged with that. It's my mindset, but I always think it's kind of funny. I don't know how I ended up. I have EV sitting in my bay here at the farm one day, and then I got a set of points in something else. And it's just because I can look back in time. So that's one of the values of having some miles on you. You have a chance to have seen so many things. Now the big thing we're looking at is straight EVs and the ADAS system full blown. So we're into the 2020s. And we now are these are rolling computers, all the interface that the driver has, and all of it has to work. All's great till the screen goes blank or you get the wrong data. I just had one not too long ago, and I was on the data one, but I chased the CAN bus problem around. That was so elusive. It actually took a couple weeks of on and off of that vehicle before I finally was able to isolate this gremlin that was in there. And as many years I had experience, if it's not doing it, not broke when you got it, how do you ever fix it? and when it would break, it would go into no start, or the tranny wouldn't shift. So, and I wasn't going to shotgun it with parts. I ended up diagnosing it, fixing it, did a software update on it, but it was an interesting experience. And I think about back in the day when I was dealing with points or feedback carburetors and so on, and this is where we've got to. So this is really what I've had a chance to do in my career, and that's what the channel's all about. I'm planning on going into depth, very of different experience I've had of going over to ETI, Equipment Tool Institute, seeing the different details, and taking some of the pieces of equipment completely apart. We'll talk about what it took to make them and what the objective was. So I really appreciate your time, and stay tuned for some more, and make sure you like, comment, and subscribe, and have the most wonderful day.